All right, fractions and decimals. We are not going to be doing too much this quarter with adding and subtracting fractions or decimals. We'll mostly be multiplying and dividing, but we're gonna just make sure we're all starting from the same place as we deal with these representations of numbers. So take just a second and think about, what do you already know about fractions? And what do you already know about these terms related to fractions? So in a fraction, the top number is called a numerator, and the bottom number is called a denominator. This is mostly important because when we're adding or subtracting fractions, we need to have a common denominator. So the top is the numerator, bottom is the denominator. Proper fractions are when the numerator is less than the denominator. So a fraction represents a number less than 1. For example, 3/5. That is a proper fraction because 3/5 is less than 1. An improper fraction is when the numerator is more than the denominator. So the fraction is representing a number that is higher than 1. For example, 8/5. This is an improper fraction. An improper fraction does not mean that it is incorrect or wrong to write it this way. That's just the title for this type of fraction. And in fact, I prefer improper fractions personally over mixed numbers. So a mixed number is when there's a whole number placed before a proper fraction. For example, 2 1/5. So in this example here of 8/5, I could rewrite it as a mixed number of 1 3/5. So 8/5 and 1 3/5 is the same thing. And this mixed number here, I could rewrite it as an improper fraction as 11/5. Now, when we add or subtract fractions, we can only add or subtract fractions that have a common denominator. So that bottom number has to be the same in both fractions in order to add or subtract them. Sometimes we have to multiply the numerator and denominator of a fraction to get that common denominator. And we'll look at that in just a second. When we add or subtract the fractions, only the numerator is changing. The denominator stays the same, and that's why it needs to be the same in both parts that we're adding or subtracting. And then we should always simplify our answers when possible. So for example, if I have 1/3 plus 1/3, I get 2/3. So see, only this top number, only the numerator changes. The bottom number, the denominator, stays the same, 3, 3, 3. On the top, though, we have 1 plus 1 is 2. Now, like I said, sometimes we have to change these things. So if I have, I'll write this a little bit bigger here, 2/3 minus 1/6. Right now, I can't subtract these because the denominator is not the same. In order to make the denominator the same, this 3 can become a 6 by multiplying it by 2. Now, if I have a fraction, anything I do on the top or the bottom, I have to also do on the other side of that line. So I can do 3 times 2 to make 6, but since I've done that on the bottom, I have to also do that on the top. So I would end up with 4/6 minus 1/6. And then again, that denominator is going to stay the same, and I really just have 4/1 is 3. And now 3/6, 3 can go into 6, so I can simplify this as 1/2. And so that's what I'm doing when I'm adding or subtracting fractions. I have to first make sure that the denominator is the same in both parts, and then I'm only affecting the top number, only the numerator is changing. Now when I multiply fractions, I multiply straight across. The numerator times numerator, denominator times denominator, and simplify if possible. So for example here, I have 2/7 times 1/2. And I'm multiplying straight across. 2 times 1 is 2. 7 times 2 is 14. And I can simplify this because 2 goes into 14 to 1/7. So what I'm doing is I'm saying, okay, I can divide this by 2 and divide this by 2. Just like I did with that 3 in the last part, if I'm dividing the top by 2, I have to also divide the bottom by 2. Now when I divide fractions, I do this thing called the reciprocal. I flip the second fraction and then multiply and then simplify my answer if possible. So if I have 4/9 divided by 2/3, I'm taking this second fraction here and I'm going to flip these two numbers and multiply instead. So I have 4/9 times 3/2. So see, the only thing that's changed is I flipped that last piece. And then I multiply straight across. 4 times 3 is 12. 9 times 2 is 18. And I can simplify from there. 6 goes into both of these numbers. So I can divide by 6 on both sides. And I get 2/3. I want you to pause this video and give these questions a shot. Okay, so with this first one, we have to start out and make sure that we have a common denominator here. And I know that 19 times 2 equals 38. So I have to multiply both the top and the bottom of this first fraction. So I get 50/38 plus 2/38 is going to give me 52/38. And I can simplify these. I'm going to divide both of these by 2. They're both even numbers, so I know I can divide them both by 2. So I get 26/19. All right, so with this second one, again, I'm subtracting, which means I need to have a common denominator between these two fractions. And I know that 6 times 4 equals 24. So I'm going to multiply the top and the bottom by 4 to get 52/24 minus 3/24. So I end up with 49/24. And I cannot simplify this any more than it's already simplified. With this next one, I have multiplication, so I can multiply straight across the top and the bottom. 10 times 9 is 90, and 24 times 19 is 456. Now with this one, it's not super clear how I can simplify this the quickest way. So when I look at these two numbers, I see that they are both even numbers. And that means I can divide both of them by 2. It might mean I have more steps that I have to take in the long run, but I'm just going to start with 2 because I know I can do 2. So 90 divided by 2 is 45. And then 456 divided by 2 is 228. Now I no longer have two even numbers. 45 is an odd number, which means I can't divide both sides by 2. But I think I can divide both sides by 3, so let's give it a try. 45 divided by 3 is 15, and 228 divided by 3 is 76. And now I can't simplify this anymore. And then with this last one, I'm dividing two fractions. So the first thing I'm going to do here is I'm actually going to convert these mixed numbers to improper fractions so that it's easier to work with them. So 3½ is the same thing as 7/2 divided by 2¾ which is the same thing as 11/4. And remember, when I'm dividing fractions, I'm flipping that second fraction and turning this into multiplication. So what I really have here is 7/2 times 4/11. 7 times 4 is 28. 2 times 11 is 22. And again, here I have two even numbers. So I'm going to start with 2 because I know I can divide both by 2. And I get 14/11. And I think that is as simplified as I can make that one. All right, thinking about decimals. What do we already know about decimals? We looked at them a little bit when we were talking about place values. So the important thing to know when we're dealing with decimals is anything to the left of the decimal point is a whole number, and anything to the right of the decimal point is less than a whole number. Take a minute to think about these equations, and you can use a calculator if you need to. All right, so if you're not using a calculator and you want to do these addition and subtraction by hand, the easiest way, I think, is to line them up on top of each other so that each place value is matched up. Now with decimals, I can add as many zeros as I want after the decimal place, and it doesn't change the value of the number. Just like with anything to the left of the decimal point, with those whole numbers, I can put as many zeros before it as I want, and it doesn't change the value, right? If I say 0003, that is the exact same thing as 3. In the same way, 0.40000 is the exact same thing as 0.4. So it doesn't matter what I add after the decimal place. I can put as many zeros as I want, and it doesn't change anything. Now, if I'm adding these, 8 plus 0 is 8. 7 plus 4 is 11. 7 plus 3 is 10. So I would end up with 10.18. Now, my calculator is my best friend, so I would just say use my calculator for these guys. 8.51, 2.479. And then especially for these multiplication and division problems, I would say use a calculator. There's not a point in your life where you'll be expected to be able to do these multiplications or divisions in your head. Now with this one here, I got a really long number with lots of things after the decimal point. So I'm going to round this to the nearest hundredth, my 2 decimal places. And remember, to do that, I look to the next one And in this case, it's a 9, which means my answer is going to be 11.15. Now, one trick that's really fun with decimals is anytime you multiply by 10, we move the decimal place one space to the right. And if we divide by 10, we move it one space to the left. Anytime it's a multiple of 10, so 100, 1,000, 1,000,000, we're moving the decimal place the same number of spaces as there are zeros. So here, if we have 9.5 times 10, we have 1 0. So we're going to move this decimal place one spot, and we get 95. If I have 9.5 times 1,000, I have 3 zeros. So I'm moving this 3 spaces. So I have 1, 2, 3, 9,500. And the same applies for division. If I'm dividing by 10, 100, 1,000, I'm moving the decimal place the other direction. So here, for example, I'm dividing by 100, so that decimal, I have 2 zeros, is moving 2 spaces.